there's an innate music module, and babies go through a period of musical babbling where they're playing around with pitch and melody and rhythm in the same way that they play around with speech sounds. And so by the age of 3 to 5, any infant who's heard music basically understands the rules of the syntax of its culture's music. So a 5-year-old will recognize that a note is out of tune, or that a note is out of place, or that a rhythm is out of place. And so that's the fundamental capacity we bring to music, that understanding that if I said to you, Robinson, if I said the pizza was too hot to sleep, you'd recognize an anomaly there. And, you recognize musical anomalies in the same way.
Hello, this is Robinson Erhardt here with the introduction to Robinson's podcast number 163. And this episode is with Daniel Levitin, whose song Too Many People I just again had on repeat before recording this, and who is also Professor Emeritus of Psychology and Neuroscience at McGill University and founding Dean of Arts and Humanities at Minerva University. He's also, beyond being a neuroscientist, psychologist, cognitive scientist, a record producer, musician, and writer. And in this episode, speaking of writing, we discussed one of his best-selling books, which is This Is Your Brain on Music, The Science of a Human Obsession, as well as some of the songs on his 2 albums, Turnaround, and then more recently, Sex and Math. And more specifically, we get into whether a neurological understanding of the mind in music ought to reduce or increase one's appreciation for music, how it is that the brain can so seamlessly process complex music, whether musical ability, both on the production and receiving end, are evolved faculties, why we get songs stuck in our head, why some sounds are more pleasing than others, and why some musicians just got it and some don't. So there is a link to Daniel's book, This Is Your Brain on Music, in the description, as well as to his music. And without any further ado then, I hope you enjoy this conversation as much as I enjoyed having it with Daniel. Do you happen to know the poem When I Heard the Learned Astronomer by Walt Whitman?
Oh, wow. I haven't read it in a while, but I have been reading Whitman. I've been reading Leaves of Grass.
Yeah, exactly.
So, yeah tell me.
Yeah, well, it's a good one. The speaker essentially becomes bored out of his mind by equations and lectures on a blackboard, only to be awestruck by the stars themselves outside. And the reason that it comes up is I was just speaking with Andy Knoll, who's a biologist at Harvard, about it, and how, contrary to the way the poem goes, he finds that the deeper his understanding of life becomes, the more awe-inspiring it gets. And now you started out as a musician, and of course you still are one. I've been listening to your music the past couple of weeks, but have become one of the leading neuroscientists of music. And I was wondering if this transition stemmed from a similar conviction, from the idea that learning more about the relationship of music to the brain would make it more beautiful, or from something completely different, like the idea that a command of the neuroscience would make you a better musician, or some combination of these things?
A great question. But first, if you'll allow a digression, I'm really not one of the leaders of the neuroscience of music. I mean, there really are some leaders, and they're Ani Patel and Bill Thompson, Lola Cuddy, Michael Todt, Frank Russo, Jessica Gran, Psyche Louis. There's a long list. I just happen to be the one that writes books about it, and so people know my name. But they're the ones. I mean, I work I do laboratory work as well, but Henk-Jan Honing is another. There's some really inspiring people, scientists in the field whose work just isn't as popularly known. But to get to your question, it's funny that you ask, because I was worried the night before I entered music school at the Berklee College of Music. I had enrolled, I'd registered. It was the night before classes were to begin, and I thought, I love music so much. What if I discover a lot about it and then I don't like it anymore? Or it just I become like a machine, and I'm playing it scientifically or something. And I never had that panic when I pivoted and went into studying the science of music. I never had that fear when I pivoted and studied the science of music, because I'd already gotten over myself. I'd gotten over my own hubris that I might actually figure out anything, which is just the arrogance of youth. You never figure out anything. It's a game of whack-a-mole. Each time you figure something out, there's 5 new mysteries. But really, I studied the science of music because I was interested in it, and not because I thought it would make my music better, and not because and I wasn't afraid that it would demystify it. As Robert Sapolsky says, science is not meant to demystify things. It's meant to inspire awe, and it does.
And that goes right back to that Walt Whitman poem and Andy Knowles' position, which is that science inspires awe. It shouldn't, if it's done well, just suck the life and the joy out of everything. But also, thanks for mentioning those names, because this is a topic that I really want to get into depth with on the show. It spares me having to ask you for people that I should invite on.
Well, I just had this experience with awe. I have a friend named Dylan O'Brien, who is a very well-known A-list music guy, session musician in LA. He played the theme for The Office. I mean, he's done a lot more things that are more fancy.
But I know that for sure.
He wrote a song called Roots and Wings, which is Joni Mitchell's favorite song by another songwriter. I
know she's a great friend of yours.
Yeah. And so she is, and a great mentor in music. But I mentioned Dylan because in the few days leading up to meeting with you, I've been trying to teach myself Martha, My Dear, Paul McCartney's song on the piano. And it sounds like this kind of cute little ditty. And like so many Beatles songs, once you get into it and you learn to play it, you realize there's a whole lot going on there. So he's got a bar of 5/4 time in there in the middle of your 4/4. He throws in an extra 2 beats. And then he's got this weird chord, which is an A flat major 9, and it just sounds gorgeous. But it's a very unconventional chord. And he just sort of, it's kind of in passing. It's like, it's there. You need to play it, but it's not there long. And then he goes to, not to get all music theory on you, but there's some notes that are part of the scale and part of the rules, and that you'd expect in a simple pop song. And he breaks those rules. He goes to a major 2 chord when the 2 should be the minor in the key. So there's all this stuff in there that's really complicated. And I'm going, man, what the hell? And then Dylan comes over, who's a fabulous pianist. He came over for dinner the other night, and I was showing this to him, because I was figuring he'd give me some pointers, and he was struggling with it too. And I realized, this is, and he was marveling at how complicated it is from a music theoretic standpoint, but also just from an execution standpoint. Paul is a great piano player. He was 26 years old or something when he recorded that, and you forget that he had all of this talent. And you were talking about awe. There's a song I liked. Now there's a song I am in awe of. Where did this come from? All this music trickery. With the awe that Dylan and I shared is that if you listen to Frank Zappa or Stravinsky, it sounds complicated. You listen to the Beatles, or especially Paul McCartney Beatles, and you think, it's so simple. But his superpower is being able to disguise how complicated it is with such a powerful melody that you don't notice what's going on underneath. And that's what I've been striving to do in my own music, is to, without having articulated it, I wanted to use unusual chords and unusual voicings so that a musician would go, wow, that's really interesting and weird. But a listener would not say, oh, well, that's weird.
Yeah, that's actually precisely what I wanted to get to. So leaving Martha, My Dear off for a moment and 4/4 timing in this unconventional chord, which might actually come right back. But as I said a couple of minutes ago, I've had your last two albums on repeat the past couple of weeks. Turnaround was the first one, and then Sex and Math. And I kind of want to use them as an anchor to talk about your research in cognitive neuroscience. And so the first track on Turnaround is called Too Many People, and it's genius, I think. And it's stuck in my head. Even though I play the drums, I lack the music theory to describe everything that's going on in the song, but the vocals come in and out ethereally. The chords are slow, but the drums are fast, and it really creates this sort of multi-dimensional landscape is the best way to put it. And the first question that comes to mind for me then is, maybe this gets back to awe, but whether or not your understanding of music theory and your understanding of the brain contribute to the way you craft something like this, or if it's more the product of intuition from a lifetime as a musician.
It's funny, the only thing that my understanding of music and the brain brought me to with this, it's not what you would think. You might think, oh, well, he knows that if he plays this chord, then it's going to hit the Framistanus circuit in the Granaspiel cortex or something, and then the frabazoid, receptors are going to go crazy. But it's nothing like that at all. It's that it was the coincidence of working on music in the brain that brought me into conversation with real great musicians about their craft and their art, and engaged me in better understanding how good records are made. And so I poured over, even before they were released in 92 with the anthology series, I was pouring over all these Beatles demos that a friend of mine at Capitol gave me. And man, the Beatles sounded terrible when they were making these demos. And I've got demos of Steely Dan where they just sound horrible. And so what I realized then in talking to people who were in the studio, and in the case of Steely Dan, talking to the band members, it's just iteration. It's working over and over and over again until it's experimenting. It's trying things out and then letting your ear be your judge. So what I got from my neuroscience work was work ethic. That's all. But the music is entirely intuitive and not at all calculating. It's just the best way for me to describe it is that I'm an omnivore musically, and when I run out of things that I want to listen to, I just go write something that's what I want to hear. And if I'm lucky, other people want to hear it too, but that's not really my main point.
No, that's very interesting. I recently spoke to the author Joyce Carol Oates about, it was wonderful. I'm a big fan of her writing.
I'm on the same podcast series as Joyce Carol Oates.
Yeah, yeah, you are.
Unbelievable.
So we talked about craft in poetry and fiction, and something that came out of our conversation was that she doesn't consciously decide which techniques she's going to use in any given situation, but it's at the same, I mean, beyond doubt that her vast experience reading and writing and then analyzing from a technical perspective, that this informs what she ends up writing. So I'm wondering if you think I'm right that this is the sense I have of your songwriting, that maybe by virtue of studying all this material, I mean, even studying the neuroscience, you're very sensitive to all the details. And from listening to so much music, you're very sensitive to all the details. So you're aware at an unconscious level of all these possibilities. And then it manifests itself this way in the music without conscious direction, maybe.
I think that's right. And then, I'll get in my head something that you talked about too many people. I always knew when I wrote it, it was going to be two voices in conversation with each other, but they'd be the same voice. I mean, they'd be my voice. And as you say, the voices come in and out. And I always knew the guitar would sound just like that. It's not like I went through, 16 guitars and different amps and sounds. That was the sound in my head. And, whether you like it or not, that's the sound I wanted, and I knew how to get it. And there it was. The same with the bass. The song began with a bass line. And I no longer have the bass that I wrote it on, but I knew how to get that bass sound. And you're right, it's detail. It's an attention to detail.
And I should take this moment to point our listeners, if they're not aware of it, to your book, This Is Your Brain on Music, which really gets into a lot of the neuroscience. But like I mentioned, there is so much going on in this song. And if you confronted the average person on the street with a chalkboard of physics equations, or if you asked them to interpret Finnegan's Wake, they'd really have no idea what to do with it. But even I, who lacks any specific knowledge of music theory, can take a song like this in and experience it and disentangle. I mean, I might not be able to pick out all of the specific notes or instruments, but it'll all cohere together in my head. I might be able to, if there was a mistake, I would notice it immediately. And what are some of the key aptitudes that the human brain has, and what are the underlying structural features that enable this sort of processing of something so complex?
Great question. We know to the extent that the average person knows the name Noam Chomsky, apart from the fact that you interviewed him, it's because of an idea that he had some 50 years ago, that we're all born with an innate capacity to learn language, an innate language module or faculty or capacity. The word module has sort of fallen into disfavor in cognitive science, as you know. But I don't mind using the word module. It's got intuitive appeal. And, there really were people who thought, in the Middle Ages that, well, Chinese people are going to speak Chinese, and even if you separate them from their Chinese-speaking families and environment. And that's not true. We learn language through osmosis and this innate language module. And the same is true for music. There's an innate music module, and babies go through a period of musical babbling where they're playing around with pitch and melody and rhythm in the same way that they play around with speech sounds. And so by the age of 3 to 5, any infant who's heard music basically understands the rules of the syntax of its culture's music. So a 5-year-old will recognize that a note is out of tune, or that a note is out of place, or that a rhythm is out of place. And so that's the fundamental capacity we bring to music, that that understanding that if I said to you, Robinson, if I said the pizza was too hot to sleep, you'd recognize an anomaly there. And, you recognize musical anomalies in the same way. And I think beyond that, the more we listen, the more we build up expectations about what is supposed to happen in a piece of music. And I was influenced greatly by Doug Hintzman, cognitive psychologist who was a student of Gordon Bauer. I was Bauer's student first, and then I went to work with Hintzman. And Hintzman and a guy named Stephen Goldinger together cemented this theory called the multiple trace memory theory, which is an old idea of the Gestalt psychologists going back to the 1880s, that the way they put it was every experience you have leaves a residue in memory. And we don't talk about residues in the brain anymore, but Doug Hintzman and Stephen Goldinger talk about everything that you experience leaves a trace in your memory, in your brain somewhere. And even if, to the extent it seems that it doesn't, it's because, well, it's kind of hard to get at it. We have problems with memory access cues, and there's a bottleneck and a bunch of stuff crowds to get out, and a lot of memories aren't distinctive. If I ask you what you had for breakfast on June 3rd, 2017, you probably don't remember because breakfasts aren't that distinctive unless that was like some, important day in your life and an important breakfast or something, right? So the memories can be in there without us having access to them. And I say all that because when we listen to music, any piece of music, it's invoking to some extent every piece of music we've ever heard before, and the piece of music we heard just before, and something that this reminds us of. And there's this whole categorization system going on where you go, oh, well, I don't know what kind of music that is, but it's, to take my song, Too Many People, you may not be able to say, oh, well, I'm not exactly sure what that is, but it's not country. It's not a Gregorian chant. It's not Chinese opera. It lives somewhere in the, poppy, rocky space of Woodstock era granola rock boomer guys or something, or maybe a little bit of an 80s, whatever it is. You've got some sense that it reminds you of things. And so you can bring to music listening all of that richness of experience. And you were talking about awe at the beginning. My friend Dr. Keltner at Berkeley just wrote a really interesting book called Awe, about the state of awe. I think the more you know about something, the more you can experience awe. It's bringing that Zen mind, beginner's mind to something you know a lot about. And you peel back the layers of the onion and you realize the great beauty and complexity that's there. And that's when awe hits.
I'd like to go back to this parallel between language and music that you mentioned, which is just so neat. The pizza is too hot to sleep is a great example. It reminds me of this sentence that I can't remember that Chomsky invented to make a similar point.
Pull this change, ungloved hand, no boundary.
That's not the one that I was thinking of. The one that I was thinking of, I think sleeps furiously or something is in there somewhere.
Yeah, I forget what that one is. I'm familiar with it too, yeah.
Yeah. But since you bring up Chomsky, there's a major debate about the innateness of language, or rather the origin of the innateness of language. And I think Chomsky's on one side of this debate. Maybe Pinker is on the other side. But the question is whether or not language is a faculty that evolved sort of directly through natural selection, or whether it is a spandrel in the sense that it's a byproduct of something that wasn't directly selected for. So I think the chin is an example that comes up often as something that might be a spandrel. So maybe the chin that the human has, I don't know the precise etiology of the chin, but I think the argument might be something like it's just a byproduct of how our jaws formed. But what I was wondering
adds new meaning to the phrase "taking it on the chin," doesn't it?
Yeah, yeah. And what I was going to ask though is if you have a particular stance on this debate as it relates to music, whether you think music is something that was specifically evolved for in humans, or if it just was a byproduct of maybe the way that we learn to process other sounds or language or something like this.
Steven Pinker and I famously have been in contention about this.
Oh, really? Okay.
So,
I'm glad I stumbled upon it.
I like Steven and we get along just fine. And we recognize that this is a point of contention, but we're civil about it and it doesn't affect our friendship. But in, I don't even remember what year it was. I wrote about it in Brain on Music, but now the year escapes me. It might have been 97. The annual meeting of the music cognition group was held at MIT. And Stephen was invited to be the keynote speaker. And I think it was in Memorial Auditorium, big room that seats maybe 350, 400 people, to the best of my recollection. But I do remember that I was sitting with David Huron on one side of me and Ian Cross on the other, two great music cognition scientists and theorists. And Pinker takes the stage, and he had much success as a popular writer, and people want to know what he thinks. And he says, I don't really know what it is any of you do, and I haven't read any of your papers, but here's why I think all of you are wasting your time. He says, music is nothing more than auditory cheesecake. It's a trick on the brain that fools the brain into thinking that it's getting something nutritive, in the way that cheesecake fools evolutionary biology that led us to prefer sweets and fats. Because over evolutionary timescales, sweets and fats weren't readily available in the environment. It took a lot of work to find them. And if you found them, you might as well store up on them. Now you can walk to the pantry, you can pull out a Twinkie, and or go to the fridge and pull out cheesecake, and it tickles all those same circuits that were designed for something else. And he says that's all music is doing. It's tickling these circuits that were designed for other things, such as language. And I remember Huron and Cross saying, "Them's fighting words." I think they said it in their best Bugs Bunny, "Them's fighting words." And it launched a very productive series of experiments on the evolutionary basis of music, led by Huron and Cross. Stephen Mythen got involved with his book, The Singing Neanderthals. Three-author big volume set came out on MIT Press that I have here somewhere on the evolutionary origins of music. And the problem is we don't have a Wayback Machine, so we don't really know. But some of the evidence, none of which is conclusive, is that when we do brain scans, in my lab and in others, we find that the circuits devoted. So I'll back up and say we talk less about brain regions now than we did 10 years ago. We talk about circuits because things tend not to be so localized as we used to think. They're distributed circuits. But when we do brain scans of people listening to music or listening to speech and we contrast them, the music circuits appear to be phylogenetically, that is, evolutionarily older. And then we see evidence for this in Alzheimer's patients who will lose the ability to recognize anything going on around them. They'll forget names. They'll have trouble finding words, but they don't have trouble with music We saw with Gabriella Giffords Congresswoman Giffords, after she got a bullet in the left hemisphere and lost the power of speech, she could still sing. And in fact, she learned to sing using melodic intonation therapy. So the idea that music exists in older circuits is intriguing. We've got neurochemical circuits that respond to music, which doesn't mean they're not co-opting, because heroin and cheesecake co-opt pleasure circuits. But it's intriguing. It was a student of Roger Shepard, Jeffrey Miller, who argues that evolutionarily music was important for mate selection as an honest signal to signal neurological fitness, because in evolutionary times, if you were making music, you were dancing. And this went on for hours and hours and hours. And by honest signal, we mean you can't fake it. You can't pretend that you can dance for 6 hours and pretend that you don't have a neurological condition if you do. And so you're signaling genetic fitness to a potential mate with music-dance.
Why does music processing, or the structures that are responsible for music processing being deeper or older in the brain, suggest that it was evolved?
So because the brain built out in layers, we started with what we now call reptilian brain, which was for locomotion and homeostasis. And the brain builds out from that core, layers and layers and layers. In fact, cortex is, means bark, like the bark on a tree, an outer layer. So what we think of as the seat of human thought, the cortex, is actually a layer. Parts of the cortex have 7 layers. Maybe there are more now that they've discovered. It's an evolving field. But the idea is that the brain builds outward. And so if something is older, it was there first. And so that's why it matters. If it was there first, that tells us maybe it evolved first.
I see. And just this is an aside, but as I listen to you, I'm struck by the quality of your memory for strings of words, like Chomsky's sentences, or even what Pinker said on the stage. But do you happen to think that this is something that was inadvertently trained by all your time spent listening to, writing, and memorizing songs, or it's just an ability you've always had?
Oh, well, it's really an illusion, Robinson. It's
okay.
My professor, the late Lee Ross, did this wonderful work on what he called the fundamental attribution error. It's a big concept of social psychology. It's wonderful. And the idea is that we tend to attribute, when we observe a person's behavior, we tend to attribute the behavior that we see as part of some stable trait, some personality trait or ability, when it may be profoundly influenced by the situation they're in. And so you take a situation like this, Lee said, where a professor is pontificating on a stage, or in a podcast for that matter. I'm only talking about stuff that I remember and that I know about. I can cover vast areas of ignorance by simply not talking about them. And the few little things that I can pull out make you think I can pull out anything. It's kind of a weird magic trick. And what got Lee interested in this was that he was, when he was when he first got his doctorate, these professors around the table for his oral exam were peppering with questions, and he couldn't believe how smart they were. But a year later, he's sitting at Stanford on an oral committee as an assistant professor, grilling some hapless student. And the role gave Lee no opportunity to display any ignorance because he's asking the questions. Whereas the role of student, he's hopelessly tied to displaying ignorance because people can ask him anything. So I take the sentiment with which you offered the compliment, and it's meaningful to me, but it's I'm aware of the vast areas of ignorance. I don't think I have any special skills for pulling things out.
Got it. Well, you shouldn't have told me that story, and I would have remained in awe. But I guess continuing to talk about memory, I told you that this song of yours is stuck in my head. And what in the brain makes this happen so often? Because I get songs stuck in my head all the time, but I'm not constantly replaying movie scenes or rereading pages from books. I mean, even though I'm obsessed with food and I have cravings for the future, it's not like I'm constantly replaying meals in my mind. It's just always songs. Songs are the one thing that happens with. I think that's pretty universal for people.
Yeah, they're called earworms, from the German word Ohrwurm. Leave it to the Germans to have a word for everything.
Mm-hmm.
And we know a little bit about them. They are universal. Something like 80% of people say they've had them. Many people have them routinely. They tend to be short snippets of a song, maybe 20 seconds or so, playing in an infinite loop, sometimes a whole song or a verse and a chorus. But most people aren't running around with Wagner's Ring Cycle in there, and
No.
or Stravinsky's Rite of Spring. And they represent a triumph on the part of the songwriter, of course. I mean, that's, for somebody to write a catchy melody, that's a triumph until it becomes irritating. There are cases where the song that's stuck in your head is just because you found it appealing. There are other cases where it's your subconscious trying to send you a message. Oliver Sacks tells the story of how he had burned a bunch of, well, he was getting ready to burn a bunch of old writings. And, he was done with them. He wasn't going to use them anymore. He needed to clear up space. He had never published them. He wanted to consign them to the fire. And he had this earworm stuck in his head for about a week, and he couldn't place it. And he asked a friend of his what it was. And it turned out to be, if I'm not mistaken, a Schumann lieder about burning children. And of course, his writings are his children. And so it was a reminder coming up from the subconscious in the way that dreams often send us things in code rather than overtly. They send us messages as metaphors.
But so what is it in the brain that is responsible for this? Is it something that we know?
No. It does point to one of my notions about the evolutionary basis of music that I've written about, and Max Krasnow's written about it as well, and others. I suspect that if music is an evolutionary development, it didn't evolve for one thing, it probably evolved for several. Simultaneously, or not near simultaneously anyway, or maybe it evolved for two or three purposes and then it was co-opted in other ways. But one of the things I think music evolved for was to preserve knowledge. So we've only had written word for about 5,000 years, but we've been around as a species for a lot longer than that. And so think about what pre-literate life was like and things that you had to remember. You might have to remember where the fruit trees are, and you might have procedural songs that conveyed knowledge songs that encoded knowledge. So how to make a watertight canoe, or how to boil this plant so it doesn't poison you, or a ballad about don't go over that hill because that tribe over there killed my Uncle Og. And, they're mean, and you need to encode this knowledge to pass it down. And we had the need to remember things for a long time before we could write it down. And songs were probably the way that our ancestors remembered things. And so, in effect, music and human brains co-evolved so that the music would get stuck up there.
No, that makes total sense. Now that I think about it, things like the Iliad and the Odyssey
Exactly.
were once sung. They were you had bards. This was a tradition where people would remember these tremendously long stories, and the music served as a memory device.
The Old Testament was sung for, I think, 1,000 years before it was written down, according to the legend anyway. And then we see vestiges of this in our own lives. How did you learn the alphabet?
Exactly.
And how did you learn to count?
I don't know if I had a song for numbers.
No?
What's the song for numbers?
Well, it's politically incorrect now. But it was 1, little 2, little 3, little Indians.
That's true. That I do remember that.
And then, I don't know if you remember this, but I learned my left from my right from a song.
No, I didn't know that one.
You put your right foot in, you put your right foot out, you put your right foot in, and you shake it all about. You do the hokey pokey.
Yeah. Huh.
And that's what it's all about.
Yeah. Okay. No, that's a really neat idea. I guess I said that Martha, My Dearest was going to come back, and I did want to talk about Martha, My Dearest. Well, the idea behind why you brought up Martha, My Dearest. So as a drummer, one dimension of musical theory that I am aware of is time signatures, and most rock beats are in 4/4 time. So,
yeah,
as you know, yeah, and some beats just sound wrong to the ear. So I hate playing 5/4, for instance, when I see that.
Yeah, 1, 2, 3,
when
4,
I
5,
see it
1.
in a textbook. And I was wondering why you think that some of these patterns sound right naturally to the ears, but others don't.
Well, so there's 2 levels to the answer. One is the first thing that the infant hears in the womb is the heartbeat. So bump, 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 bump. So there's a 2 beat.
Oh, wow.
There's a space between the second one and the first one. And so if the circuits in your suprachiasmatic nucleus or your cerebellum are synchronizing to it, they're going to have to figure out what the blank interval is too. But the noised part of it is 2 beats. When we walk or march, that's 2, right? Marching. Hut, 2, 3, 4, hut, 2, 3, 4, right? When we swing, it has a natural 3 rhythm because as you reach the peak of the parabola and it hangs there before it comes down. So if you're swinging like in a hammock or in a swing, 1, 2, 3, 1, 2, 3. So you get 3, you get waltz time out of that. But so the first part of the answer is there are these biological components. If you've ever run in what we would call a canter for a horse, where instead of running like a jogger or running like a sprinter, you lift off one foot and allow yourself to glide, and then you set down and you glide again. A canter, that's got a 1, 2, 3 feel to it, and that's an efficient way to run. So because you're launching rather than stepping each time. So these are biological givens, but the reality is there's a cultural overlay. Music is cultural. There was an ethnocentric view that persisted for many, many years that, if only we could go to the Ural Mountains or sub-Saharan Africa and play the Mozart, they would accede to the superiority of our music because of Mozart. And it turns out not to be true. Bill Thompson and Laura Lee Balkwill and others have done that experiment, and many times over. Western music is not superior. Mozart is not superior. And many cultures have polyrhythms where rhythms are playing against one another. There'll be rhythms of 7 or 11, and they'll have notes that don't line up with ours. And so the rhythms that feel right to you, Robinson, and to me are based on what we've been hearing most of our lives. And it's why to us, if you hear a xylophone doing a chromatic scale, bum, 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 you might be thinking of Bugs Bunny climbing stairs or something. But that's cultural. It's learned.
I expected that one part was going to be learned based on the music that you were exposed to. I wasn't expecting the heartbeats or the swings or marching. That's all very fascinating as well. But one thing that I thought that you might have mentioned, and this came up when I was speaking with Chomsky, was that there are certain languages, certain types of languages that the brain just inherently can't process. He called them impossible languages. And this is one of his issues with the large language models and why he thinks we can't learn much about human language from them because they have no problem with these quote unquote impossible languages. And I thought that what you might have said was not necessarily that there are impossible musical patterns or something that our brains can't process, but the way that our brains evolved, there are just some patterns of music that the brain doesn't like, maybe something like that.
Well, so if it is nothing else, the human brain is a giant prediction machine. It's trying to figure out what's going to happen next. It's evolutionarily adaptive to do that. And music is this wonderful game for the brain because most music that we like, not all music, but most music has a steady beat. And so you pretty much know when the next event's going to happen. If you know exactly what it is, you're going to grow quickly bored of the music. So this would be a very boring song. Bum, 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 bum. But I can fix it. Bum, 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 ba da 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 dum, bum, 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 bum. Right? I kind of fixed it. Not the greatest song in the world, but I got your prediction device kind of engaged there. That's in Brodmann area 47, we think, on either side of the brain here. And just apropos of what we were talking about earlier, I can't tell you what all the Brodmann areas do. I just know about a few of the ones that I study. But so there is music that I think the brain doesn't like, and that would be either music that is basically just that, completely as Claude Shannon would say, the information content is such that there's no information there at all. It's entirely predictable. And the other thing we wouldn't like is, one would predict, is 12-tone music where there's no relationship across the notes. Serial music, computer-generated tones that, don't 12-tone music where we violate the tonal hierarchy and scales and things, and we just choose notes at random. There's no ability for the giant prediction device that is your brain to actually grab a hold of anything. And so for that reason, I think that members of our culture tend not to like music of the Cameroon Pygmies or Chinese opera because those are working under different systems. And it's why the Cameroon Pygmies probably don't like Mozart or Taylor Swift very much.
Interesting. Yeah, I like this idea of the brain as a prediction machine. And it makes me wonder, though, why some surprises in music are experienced with enjoyment and some we really don't like them. And I noticed this in one song on your album, Sex and Math. The song was Headed for the Fall, in that there's a purposefully dissonant progression that repeats a number of times, and it's downward, so it kind of mimics falling in a sense, like in the title. But Do you know what I'm referring to in the
Yeah, it's
song?
an A11 chord in the middle of all that, which is a dissonant chord to begin with. Yeah.
Yeah. But despite its dissonance, it totally adds positively to the
And it
song.
goes by quickly, right?
Yeah.
It's a dissonance in between two consonant B minor sevens. So I can demonstrate it for you.
This is a first for Robinson's podcast. That's a very beautiful guitar.
Thank you. My friend Tom Brousseau gave it to me as a gift. So the basic riff of the song is in a B minor 7. And it has two dissonant turnarounds in the verse. When I was a child, I never learned to swim. These are dissonant technically. They're augmented chords. This one kind of fits the key, because if I went like this, I'm sorry, it kind of resolves. But going here, that's jarring.
Right.
And then on the way down where it's falling, I got to get from here to here. Down, down, down as I start to lose it. Down, 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 down as I start to lose it all. And so the way I actually play it is down, down, down. And I think you're hearing this.
Yeah.
And it's in passing. So, and you're right. It for me, after the fact, it evoked in my head this idea that you're not just falling, but you're tumbling against rocks or something. I mean, there's some,
Yeah.
but it goes by quick enough that hopefully it doesn't upset you too much. It's just, but it's surprising.
Right. No, I noticed it, and it was surprising, but I liked it. And that's what I was wondering about. If you have any idea why it is that this dissonance is pleasing as opposed to some other dissonances.
Well, I've had a wonderful experience in the last few years playing with Victor Wooten, a friend of mine who's a bass player, and we performed together as a duo, and we've toured. And in Victor's mind, there is no dissonance. You can play anything you want, but it's the context. And this goes back to an old concept I had forgotten from Leonard Bernstein's Norton lectures at Harvard in the 70s. Dissonance is contextual. You can get away with a lot depending on what's happening in the song, how you got there, and how you get out of it. So if you listen to some of the jazz players, they'll make mistakes. And some players, like McCoy Tyner, after they make a mistake, they'll go fix it. Other players like Miles, they play a note that sounds wrong or that maybe they didn't even intend. They'll just hit it over and over and over and over again until they've normalized it, right? But in the so that's really the context of soloing. But in the context of a song, generally you're trying to get from here to here. The song is a journey, and you normally begin and end on the same chord a lot of the time. And so everybody knows you're going to end on the same chord. The question is, how are you going to get there? And are you going to get there in an interesting way? And you'll tolerate a whole lot of dissonance, it turns out, if there's a rhythm going. That's where you as a drummer understand that. If you can keep the beat going, and like if you were in the band with me and we were playing that tune, the worst thing you could do would be to stop your beat and let that oddball chord hang out there like a matzo ball. Or, if you were to just crash your cymbals with it, the better thing to do is regularize it and just let it, go along with the flow, which you would probably do, being a sensitive drummer.
Yeah. Well, this is also an example, though, when as an artist, you're knowingly making a a mistake, but it's to achieve a very targeted effect. Like in this case, to emulate falling on rocks, which might, like tumbling off of these rocks, and it might superficially make the song less tasty in the sugar or fatty sense, but it's very complex. It makes it complex. And we could carry this sugary, fatty metaphor farther. I mean, if you're going to a 5-star restaurant, they're not just going to serve you Toll House chocolate chip cookies. They're going to be giving you something that's very interesting. Like if you're going to a 5-star sushi place in New York City, they're not giving you Neapolitan style pizza, which to me is like the tastiest food, but they're giving you seaweed and 5 different types of sea urchin, because they're not just going for the sweets. They're trying to make something complex and sophisticated and tell a story.
That's a nice analogy. I have to say, in this song, in all my songs, there's nothing intentional in the writing or performing of them where I'm thinking, oh, I'm going to use this chord because it sounds like tumbling off rocks. It's only after the fact, when you asked me about it just now, that I realized, oh, well, that's the effect that it has. For me, as you said at the beginning of our time together, it just comes from intuition and me trying to express myself and let things happen. And I remember working a long time trying to find that chord, not knowing what it meant or why I wanted it. As I said, I knew I needed to get from here to here. They're the same chord, but different voicings. And I knew it needed to go, it needed to stop somewhere along the way. And it was just painstakingly that I figured out, it was not this, but this. That just, and I can't tell you where it came from other than just fumbling. And that's one of the things I learned from Joni about writing, is that writing is an act of discovery. From Joni Mitchell, but you play around with different things. In this case, I had something vague in my head, and it was through the act of playing that I found something that was allowed me to solidify that vague notion into something concrete. And the same happens when after I run an experiment, I'm trying to write it up. I have some vague notion about how I want to express it, and then the act of writing the words and get out what's in my head onto paper, and then it comes staring back in the paper, and I go, well, that's not what I meant, or that is what I meant, but it's not the right way to say it.
Going back to Taylor Swift and Pygmies and Joni Mitchell, who you just mentioned, at the beginning of This Is Your Brain on Music, you say that one reason you went back to school to learn about cognitive neuroscience and music was to better understand why some musicians had the it factor that makes them household names. And I've also wondered that and wanted to ask about a few particular musicians to see if you had insight into what was so special about their music and how it interacts with our brains. But Joni Mitchell and Taylor Swift were two of those people, actually, that I was curious about. What it is about their music that has made them so enduring.
I think certainly in the case of Joni, I'll put out a caveat that I think Joni was of a time, and she means something to people of my generation, and possibly to people somewhat younger than me. But I don't think she means much to the average 20-year-old. It was a time and a place. But I could be wrong. But that, from talking to to younger people. That's the impression I get.
Yeah, my mom's probably about your age, and she was a California girl. So Joni Mitchell is very important to her, and consequently it sort of rained down on me and my sister.
Yeah, so it was two things with Joni. One was she was writing about, as were some of her contemporaries in the Woodstock generation, writing about the lifestyle and the ideals of the Woodstock generation. The peace and love and take care of the earth and the environment and don't cut down all the trees. And she was also writing about relationships in a very frank, honest, and intimate way, and writing about self-doubt. And for a woman that many people found to be beautiful, to be writing about self-doubt was very affecting. And it was her fearlessness, her willingness to expose things that one normally might not even talk about with one's best friend. Her openness, authenticity, and fearlessness as an artist. And we see this, in painters and sculptors and dancers and writers as well. And her willingness to explore new modes of expression. She lost a lot of her fan base when she made an album with Charlie Mingus, but it's what she wanted to do. And I think even people who didn't like that music respected her in the way they respected Miles Davis for his going rock and roll with Bitches Brew and, just constantly exploring the real artist's nature. I think people who are not, whether you're an artist or not, there's a certain amount of admiration we have for people that are constantly pushing themselves and willing to grow and not being complacent. Certainly, I feel that way about scientists that push themselves and don't just rest on their laurels, and writers, everybody, politicians. And then Taylor had a similar, with her first album, a similar self-examination and a similar confessional introspective style. I have to say that I haven't followed her since then. So I couldn't say. I mean, it's not my jam, but people seem to respond to her in very powerful ways. And I just heard on NPR yesterday that one of the major magazines has assigned a beat reporter to her full time and another one to Beyonce. And, I think they are having an effect on people the way the Beatles and Joni did on me and Miles. And I think that's great. But if you're asking me what the appeal is, I would speculate it has to do with some sense of authenticity and an intimacy and a giving expression to things that most people don't talk about.
Well, I hear everything you said. So openness with regard to Joni, openness, authenticity, and fearlessness. But what I expected you to say was something about the mechanics of a song like California, which is my favorite. That makes it become an earworm. But maybe I should ask if, and this is the last thing I'll ask in ending our conversation.
Oh, well, could I interject? Could I interject there?
Yeah.
I think I love talking about the mechanics of songs, and most of my friends are songwriters, and we do spend a lot of time talking about the mechanics. But ultimately, the mechanics are there to serve the authenticity, not the other way around. And it's fun to kind of deconstruct something and figure out how it works and what's going on in it from a technical standpoint. But if there isn't authentic expression behind it, who cares?
Well, that's a good point. That's what I was going to ask, because authenticity is Authenticity is in general not what people associate with pop music. It's something about the mechanics of the song, the sounds that are going on that make them so infectious. And I was wondering if in ending you have any insight into what it is about current pop music that makes it so infectious, just to use that word again. Or maybe it's not really an enduring feature of the music, and it's just something, it's fleeting. It's just the taste of the time.
Well, great question. So I think I would make a distinction between pop music, meaning popular music, and art music. And the line isn't clear. It's it's probably what Dom Mazzaro would call a fuzzy boundary. But there are some clear cases on either side where something is clearly one and not the other. If you want to think of it as Wittgenstein and his categories and family resemblance is a way to think, perhaps conceptualize it. But I think of a lot of what Joni did as art, and some of it became popular. I think a lot of what we hear on the radio is designed to be consumed by the masses. It's more like the wall-hanging art you would buy at Target to put on a hotel room wall. It's supposed to be there and entertain you, but not require a lot of deep thought. It's the background to a party. It's the soundtrack to a day at the beach. It's fun. And I like a lot of fun music like that. I'm not a snob. I love a good pop song. I love Paula Abdul when she came out. And I was just listening to, I don't even know the names of all the artists anymore, but, there are people making records now that are doing that same kind of thing. It's fun, pop, light music. So where's the authenticity there? Well, the authenticity there is to an art form, which is, an art form which is popular music, an art form which has its own rules and its own, how to put it? It's, when I think of Twisted Sister or Motley Crue or Kiss, theatrical rock, glam rock, I think that's the best analogy I can think of to most of what's on the pop music charts, which is that it's made for a certain conception of fun music, and that's a thing, and that's it's not an authentic expression of the artist's inner angst necessarily or self-exploration. It's playing around with a different form. That's all. Does that make sense?
Well, no, it totally makes sense. And Daniel, this has been so cool. We covered a lot about your songwriting, touched on some of the topics at the intersection of neuroscience and music, and it will hopefully poise the show for some deeper explorations of some of these issues with the people that you named at the beginning of our conversation. But I'm definitely going to point our listeners to one, this is your brain on music, and then to your albums. Just a Memory was another song on Turnaround that we didn't get to that I totally loved. But thanks again so much for doing this with me. It was really a pleasure.
Thank you, Robbins.
Hold on. If you haven't subscribed, liked, commented, or reviewed, that would be so helpful. And if you haven't yet, you could also follow me on Twitter and Instagram at Robinson Erhardt.